All right, we are back starting. I think this is my seventh day coding. It says start day 9 here, uh, mainly because I think the last few days I've been doing like 2 lessons. So we'll probably try to do another 2 on a 3-day coding streak. So let's keep the streak alive. Casting spells on code. Oh, can you see that? There we go. All right.
It's day 9 and we're going to deal in casting. No, I'm not going to teach you some magic like Harry Potter. We're going to look at how we can use numbers in an effective way. Okay, until now, you probably tried using numbers in some of your questions and some of your answers, and you can't do a lot with them other than just checking that the user's typed in a number in exactly the same way that you've asked. Well, that's a bit of a lie, because if statements don't just support our double equal symbol, they support this entire range of symbols that you can see at the moment. These questions are called inequalities. We've got not equal to, so if both boxes are different, that will trigger the if statement. We've got less than, greater than or equal to, less than or equal to. All the classic inequality questions. But if you try to use any of those inequalities, greater than, less than, the way we're doing it at the moment, it just won't work. And the reason for that is because the way input has been working behind the scenes is that input always assumes that what you type in is text.
A
In other words,
string.
gets stored in a variable with quotes around it, assuming it's a string. Now, that's a reasonable assumption on the part of the computer because it's being typed in with a keyboard, and a keyboard, as you imagine, turns out to be mostly letters. But in certain cases, we want the user to type in numbers, and we want the computer to specifically refer to them as numbers. And the way we do this is with a process called casting, where we explicitly tell the computer what you're expecting to be typed is going to be a number. Now, just a little warning, we do get some crashes if the user tries to type
Going on
anything else.
1.25
That's perfectly
speed.
normal at this
It's
point.
a little slow.
Don't worry about it. Okay, we're going to start with this piece of code that I've written very simply to incorporate the different equality symbols in the if statement addition. In other words, I've written a question that says, what score did you get in our game? Any number over 100,000 should make the computer say winner. Anything less than that should cause it to say try again. Why don't you go and try it and see what happens, and then we'll do it together. Okay, so hopefully you saw the same sort of thing happening. Let's say that I got just an amazing score, well over 100,000. Well, it completely crashed the program. It didn't even not work. It completely crashed it. Now let's try and decipher that error message a little bit. It says the greater than symbol is not supported between instances of string and int. Well, what does that mean? Well, have a look at the way that I typed a number in. I put nothing around that number at all. I type that number in absolutely as it comes. That's because, to a computer, a number wouldn't have quotes around it. And that's quite interesting, because that means when input works and the number goes in, the computer puts quotes around it, and as far as we're concerned, in our variable box, that is the text version of that number. How do we tell the computer, hold on, sunshine, that's a number? Well, it sort of depends on what kind of number it is. There are 2 types of number that we need to care about, an int and a float. An int is a whole number, in other words, there's no decimal part to it, and a float is a number that we expect to have a decimal. It only matters what you pick here if what you're expecting to be typed in is going to be different. I want a whole number for this score, so I'm going to use int. And what I'm going to do is, in front of my input, I'm going to type in int and place the entire input in brackets. Now, of course, the order at which the computer is evaluating this expression is important, and it does the brackets first. So the first thing it's going to do is this. It's going to put your score on the screen and take that value in from the computer. Now, at this point, it still has quotes around it, so it thinks it's text. What the int part does is it says, hold on now, sunshine, this isn't text. This is a whole number. Can you convert it for me? And the computer goes, oh, it is a whole number. Wow, here, have the number back. And essentially, just removes those quotes and hands it back to you. Then it stores it in the variable myScore as a number. When we come down to that if question again, it's able to compare 2 numbers. And if one of them is bigger than the other, it will trigger the if statement. Let's try it. Well over 100,000. And I'm a winner. Let's check it works though. What if I had such a bad run that I got minus 100? It works perfectly. We're now able to take any input
Pretty simple.
and turn it into a whole number with int.
Integer,
what about a decimal?
int, float,
In this example,
decimal.
I'm doing exactly the same thing. I'm asking my user to type in pi to 3 decimal places to see if they remember what it is. And all I'm doing is casting that input as a float. That means I'm expecting a decimal. And so it won't crash if I put a dot and then the numbers after it. Let's test it out. Boom, worked perfectly. Let's get it wrong. And the if statement is matching up those decimal numbers with reasonable precision, which is really, really good. Okay, common errors you might be getting this. Well, the most obvious one is this. This is the most common error we get. This invalid syntax error is because we haven't actually finished the brackets on line 1. But look where it tells us the error is. It tells us the error is on line 2. And this is a common problem that we get when we're combining lots and lots of brackets together now. Just remember that on each line, where there's an open bracket, there must be an equivalent closed bracket somewhere. So in line 1, we have 2 open brackets and only 1 closing bracket, meaning the problem is there. Where the brackets are placed does have meaning, so please don't just throw them in willy-nilly to see what happens. Try and use your logical approach to working out where they should go. Casting is saying, take what the user types in this bracket and turn it into an int or a float, whatever we're looking for. And then we can do mathematical comparisons to it. Why was the error in the wrong place then? Well, as far as the interpreter is concerned, that line hadn't finished. Line 1 extended onto line 2, and then something weird happened in line 2. So clearly, the system is trying its best to guess where that error could be. You've got to be mindful of that. Oftentimes, the error will be in just the wrong place entirely. Always look at the previous line, just in case you've missed out brackets or quotes that could be causing it to think that that line runs on forever. As usual, if you want another extension activity, I've broken some code and placed it in the REPL of this. Go and fix it if you want a further challenge. Your challenge for today. We're going to work with a person's age in years, and we're going to tell them exactly where they sit in terms of the type of generation they are. Personally, I'm a millennial, but we've got this list of generations and the years in which they were born. We would like you to ask a user to type in the year they were born, and from that, identify which generational group they belong in. Please share your project with us in the community with the publish button and on social media, and make sure to hashtag it with Replit 100 Days of Code so we can all see what cool stuff you've been getting up to. Data.
Okay. Okay. Are those the... Was that?
So we can all see what cool stuff you've been
Generation
getting up to.
Alpha? Wait, where's Generation Alpha? It's just... It ends at 2015?
Please share your project with us in the community with the publish button and on social media, and make sure to hashtag it with Replit 100 Days of Code so we can all see.
Okay, this video's old, but here's the actual date range. Okay, so did I click
what cool stuff you've been getting up to. Please share.
Which year was you born? Question, response. Okay, let's do it. Close. Alright, print. Hi there. You're about to find out which generation you belong to. Print space. Age equals int input dot how old are you? Okay. If age is greater than greater than 2015. Print youngin, your generation alpha. I think. Yeah, okay. If age is greater than 1990, ELIF, else if age is greater than 1995 and age less than or equal to 2015, print you are peak Gen Z. What's your fave TikTok dance? Okay. Elif, age greater than 1991 and age less than or equal to 1996. Print. Brother, you're a millennial like me. Elif, age greater than 1991? 1981. Millennial. 1964. 1964 and age is less than or equal to 1981. Yeah. Hold on. No. Greater than 81 and less than or equal to 94. No, 95. Age is greater than 1964, 65. Yeah. Print. Up there, huh? You're Gen X. Elif, age is greater than, that's Gen X, is greater than 1946, and age is less than or equal to 1964. 64. Print. Boomer. Boomer alert. Elif, age greater than, oh wait, no, else. Else, print traditionalists. How did you survive the Great Depression? We're on our way. Need tips. Okay, how many issues am I gonna have? Let's run it. Okay, line 8, first issue. Fudge. Elif. Invalid syntax. Elif. Oh, whoops. I don't know why I was doing this. Else. Age. Haha. How old are you? Wait, no. What year were you born? What year were you born? I was born, let's say, 1990. Brother, you're a millennial like me. Cool. Let's say 1965. Up there, huh? Gen X. 1960. Boomer alert. 1998. You are peak Gen Z. Okay, 2001. Is that still peak Gen Z? Oh yeah. 2020. This should be the COVID generation, actually. What's the last one? 1900. Okay, cool. Done. Mark lesson complete. Okay, starting day 10. How long was that? I don't know. All right. Show me the money. A little bit of math.
It's day 10. Time to introduce the computer to a little bit of math so that all the complex calculations in the world can be worked out by this super quick brain that can do math faster than we can think. So far, we've introduced the computer to the concept of numbers, and we've got two kinds: floats, which have a decimal, and integers, which are whole numbers. All of the math we'll be looking at today is very, very straightforward, but can be applied to both sets of numbers. Now, in a computer, we can set a variable to the result of a mathematical function. This is a very, very simple way of doing math and printing out the answer. The mathematical symbols that we use are the standards of addition and subtraction, as well as multiplication and division, represented by the asterisk and the forward slash symbol, as well as two interesting concepts: modulo or modulus, which is the remainder of a division, the divisor, which is whole number division. All of that stuff is really useful, and it's stuff that we can use over and over again, and we can combine with brackets to do amazing things. In terms of all the math you could encounter, here's a basic rundown of the usual suspects. Adding is just using the plus symbol, subtraction, the minus symbol, multiplication uses an asterisk, division uses the forward slash. To raise something to the power of another number, we're going to use two asterisks. We're going to use two asterisks. Modulo is the percentage symbol, which again gives us the remainder of the division, and divisor gives us whole number division and is accessed through two forward slashes. Pause the video, copy that out, mess with the numbers and see what happens. See how they're working things out.
Let's do it. I care about this one. Let's do this. What? Copy. Paste. Can I just run this? Ugh. What? Okay. Multiplication equals 5 times 10, 6 times 10, print, multiplication, 60, okay, let's do, whoops, 10 divided by 2. 5. Okay, let's do this. Wait, what's the double divisor? see. Divisor 3. 3? Okay. Modulo. Dude. Modulo. This should be like 1. 3? What the fuck? Oh, I'm doing the wrong thing. Percentage. Is this 1? 1. Okay. Cool.
If you want a challenge, once again, I've broken some code and put it there for you to please help me fix it.
Fix my code. Excuse me. Firstly, copy each code snippet below enter may apply by clicking the copy icon at the top. Green. Solve the following part of my code. Your goal is to print the solution of all 3 calculations to the screen. Okay. Multiplication. Did I do multiplication parentheses? No. Print multiplication. Yeah, right. 3.4 times. I'm checking. Oh. Okay, so the next thing, I don't know how to like round up after 2 decimal places. Okay. Division. So this is just division equals 2467 divided by 4673. Print division. Okay, and then if we wanted to do divisor, divisor is a percentage? No, divisor is 2. What is divisor? Divisor 15 double 2. Okay, so this would be like 7.5, right? Divisor 7. Okay, it's what you're going into it, and then remainder is modulo's percentage. Okay.
We're going to start by building a very simple program to break the bill up between you and your friends when you've gone out for lunch. Our first job is asking the user what the bill amount was, and we're going to store that as a float in a variable because it probably will have a decimal. Our next job is to ask for how many people there were in the party. I've stored that as an int because the number of people is likely to be a whole number. It's very irregular that 0.3 of a person comes for lunch and the other 0.7 stays at home. Now, to work out what contribution each person would make if they go Dutch and split the bill, we just need to divide the bill by the amount of people. So, our answer is going to be equal to the bill divided by the number of people. I'm going to print that out. I've concatenated that answer together with a bit of a sentence to make it make sense when we run it. Let's assume that we had a bit of a party and spent $80 on food between 4 of us. That's some math we can probably do in our head.
Cool. Now we're getting somewhere. This is something I would use. My bill equals float. Float. Input. What's the damage? My bill. Okay. Yeah, number of people. People equals int input. How many of us were there? Cool. And then print. Oh wait, and then O equals my bill, oops, divided by people, right? Print y'all each O. Oh yeah, duh. Quotes. What's the damage? Let's go 40, 50. How many were there? There was just 2 of us. Y'all each owe 2025. Alright, cool.
Heads. Well, we owe $20 a piece.
I'm gonna use
Let's
this.
try it with a bit more of a complex sum. Let's say we spent $120.32, and we're splitting it between 7 of us. Well, whoa. Okay, first of all, thank you, math, but I don't happen to have 18.85714285743 cents on me today. How do we normally deal with that in real life? Well, we round up. So a sneaky extra skill is the round function. What we can do is we can take our answer and make it equal to the rounded version of the answer. Round has 2 arguments. The first one is what am I rounding? The second one is how many decimal places? And I'm going to pick 2. And this will properly round up, round down. Well, that's a lot nicer and gets the answer a lot quicker. Hold on, David. Were you raised in a barn? We have to tip. Well, in fact, that's what your challenge is going to be. You're going to attempt to build something that calculates a tip based on a series of different percentages. You're going to write a program that asks the user for the total bill. You're also going to ask them for the percentage of the tip you want to get. 5, 10, 15%, it's up to you, let them type it in. You're then going to multiply those 2 values together to work out what the tip amount would be. You're going to add that value to the original amount, so you've got a total for the bill. You're then going to ask for how many people you want to split the bill between, work out the division, and output the answer on the screen. Don't forget to share your code. We'd love to see what you've done. Remember the hashtag Replit 100 days of code to make sure your code is seen by as many cool people as possible.
Okay. Let's figure this out. But then we want to do O equals round. Shit, what was it? Okay, let's split the bill. How do we get to round? Round. Answer equals round O to 2. What's the damage? Let's say 60.30. There's 6 of us. Yeah, 60.30 divided by 6. Oh, fuck. Too much of an even number. 55.11. 6. 55.1 divided by 6. Cool. Rounding it up. Okay. So in this question, how much do we owe? How many of us were there? Okay. And then tip. Int. Input. How much do you think we should tip? If tip equals what percent? What percent do you think we should tip? If tip equals 20, then O I feel like it's like we're doing variables. O equals O times 1 plus tip. That's a decimal. How do we make this a decimal? There's an easier way. Okay. Well, O equals tip divided by 100. O equals O times 1 plus tip. If tip equals 15, I don't know if this is gonna work. LF tip equals 10. Else O equals O. Otherwise print we each print we each okay. Fuck. So total tip equals that. Tip total equals O times 1 plus tip. We each owe else total equals shit. Okay. My bill divided by tip total equals I'm all over the place right now. I forgot I already had this. So my bill, people, O, okay, and then that's O rounded. So if the tip is 20, tip equals tip divided by 100, that's 20%. Total equals, yeah, O times, okay, print we each O. We each owe total. Shit. And then for this one, if we don't say anything, else print screw it, will each pay O. Let's see how this works out. Okay, line 20, no, line 8. Line 8, if tip equals 20, if tip equals 20, is this really two equal signs? Yeah. Line 11, print we each owe what's wrong with that? Oh, is total undefined? Yeah, total's undefined. Total equals O times 1 plus tip. I don't know if this is gonna work. Maybe we don't need this. We each owe total. Do we need total? Okay, let's try that again. Ah, we each owe total. Oh, that's why. The comma is outside. We each owe. That's why. Aha! There we go. Aha! Okay, let's just make the math simple. $100.50. We don't need to do, yeah, let's just do $100. How many of us were there? There was 2. What's going on? What percent do you think we should do 20? You owe $60. Yeah. Right? 120 divided by 100. Okay, let's do that again. What's the damage? 100. 2. What percentage do you think we should tip? Let's go 10. So it should be 55. 55.1. What the fuck? Okay. I said 10. Damage. 100. 2. 5. Screw it. We'll each pay 50. Cool. What's the damage? Okay, let's try this. 1325.23 times 1.10 divided by 10. Wait, it was 1.20 equals that divided by 10. 159.024. Where I screwed up? 1325.25. Wait, how many? There's 10. How much do you think we should tip? 20.027. 1325.23. Why is this off? Oh, I know why. I'm rounding UOO total. Okay, so then I should do total equals round total 2. Okay, let's try this again. What's the damage? I forgot what it was. 1325.10. How many of this were there? There's 10. Let's tip 20%. What? I thought I'm rounding the total now. Round total to 2. Do I need to round the tip? Tip equals, wait, no. (1325.10) times 1.2 divided by 10. 159.012.01. So that's right, but why isn't it rounding it up? I want it to be perfect. Why isn't it rounding it up? Tip. Total equals O times 1 plus tip. And then total equals round total 2. Why? Oh my god, this is bugging me. Oh. I'm not using int. Tip is int. Total. Are all these numbers? Okay, so I'm getting the float. 20. Oh, 20 is an int. Let's do this. I think this is why. Because it's turning into a decimal point. Is the only thing that I can think of. I don't like that number. 10, 20. No! It's 15621.21. times 1.2 is tip, divided by 10, 1874.54. So, yeah, why is it putting so many, what? I did that, divide, okay, cool. Ask the user how many people are splitting the bill. My bill, float input, yep. Number of people in, yep. Answer equals my bill divided by people. Y'all, okay. Is that it? I'm not happy about this though. How do I fix that? Let's try. Five, 6, 223.13 times 1.15 divided by 10. 6465.65. Oh. Oh, the division. It's the division. Hold on. I need to do double division. I'm pretty sure that's it.
How's the live stream tonight?
I don't know.
Who's
Hold
tuning
on.
in?
Hold on. What's the damage?
How many are
there?
Do you have?
None. 10, 15. Oh, I got it. 47173. 47173.18 times 1.15 divided by 10. Wait, what? 47173.18 times. Wait, what? This is totally wrong now. 47173.18. Oh, wait, that's divisor. Division. Whole number division. No, yeah. That's not it. Come on. How many are there? 10. 10. 481.93 times 1.1 divided by 10.
Honey, why are you doing math?
What are you doing?
Me and my girlfriends are tuning into the live stream.
No, you're not.
Yes, we are.
No, you're not. Hold on, I'm trying to figure this out.
But what are you doing? Just tell the people what you're doing. Besides your crazy hair that needs. Honey, don't get shy. You have guests watching.
I'm trying to do this.
What
Code.
are you doing?
I'm learning how to code. I'm doing days of code. That's all I'm doing. I'm building out a tipper. This is bothering me. Why can't I figure this out? I don't like that it's doing that. 41.93 times 1.1 divided by 10. It's the same fucking thing. 53.01. Why? I do not want to give up. Okay. Let's copy this. Let's cut it. No. Yeah, let's cut it. And let's just do math. Number. Okay, let's just do this. Actually, let's no. Okay. I thought I pasted it. Float. Int my bill over people. Round O to 2. Total. Is there another variable? Tip float. I got that. That's not a float though, but int, because it is an int. This is so annoying. 100. $15. What? Oh, I did this wrong. Close enough. I'm marking it done. Alright, I'm calling it. That defeated me. Now use your newfound math skills to determine how many seconds are in a year. Tomorrow.